Bergson and the Holographic Theory of Mind, Part 78. A quick look again at ChatGPT. Again, Commonsense returns to bite us. And just a quick relook at its graham cracker crumble foundations. A little bit of, shall we say, common sense thrown in here. Last time, I noted Jordan Peterson's comments on ChatGPT. He was quite worried. Its statistical analysis based in neural net architecture, analysis of text, would be paired, he thought, with interaction with the concrete world. That is, it would interact with coffee stirring. That is, truly interact with that physical transformation of coffee stirring, which, as we've said many times, involves invariant structure. All invariants only defined over a continuous time, velocity flow fields, adiabatic ratios, inertial tensors, etc. So for that experience, this is what the AI would have to actually come to grips with, truly interact with. I noted statistical analysis. A simple example is the man stirred the coffee with a spoon up there with the blank. And then statistical analysis of text would fill in probably with the highest probability a spoon, followed with lesser probability by a knife, then maybe by a straw, and then maybe by a toothpick. So you've got probabilistic, never an actual true answer, but a probabilistic answer of what can be found to fit there. And this simple approach, however, can be is obviously, in ChatGPT's case, womped up, shall we say, into a very powerful tool, which we're not denying here, but we're looking at in principle problems. And I noted this still leaves an impassable gap because you've got two different visions. In the one vision, you have a brain resonating in symmetry to the external event and that structure, its invariant structure, over an indivisible flow of time. None of these invariants exist, say, over an indivisible flow. And this resonance also being the equivalent of a reconstructive wave passing through a holographic field, then specific, therefore, to a source within the field. In this case, the coffee cup, liquid surface stirring spoon, just as in the little red picture above, that reconstructive wave is specific to an image, virtual image of the coffee cup in space. In this case, the brain is passing through the hologram plate, being the universe, a dynamically changing hologram plate. On the other hand, we substitute a Turing machine, essentially, neural net or not, still a Turing machine, with this discrete state time, attempted to affect, by storage in its memory, state by state, the understanding, that is the experience of the coffee stirring. As we noted, this is a gap. It's a gap, therefore, of both phenomenology and time. Phenomenology, because in both cases, there's nothing like the coffee cup, either in the brain or in the Turing machine or in the neural net. And of time, for one thing, because that event is in the past. So unless you have a different metaphysic of time, which this first vision does, you're going to be forced to try to store that event state by state by state in a memory to try to grasp this dynamic flow. But that brings up unsolvable problems, as we discussed in the last one. So in principle, this framework cannot solve AI's common sense knowledge problem. We'll find problems with analogy and translation, simple failures in common sense. Here, I just want to look at the implication of a ChatGPT incident, we'll call it, that surfaced a few days ago. This appeared February 6th on Twitter. So here you have Aaron Sobarium noting that he asked this question, the query, and the query comes down to this. You have a bomb. If it goes off, it will kill millions and millions of people. Okay, so it's a bomb. If the bomb explodes, it will kill several million people. There's only one way to disarm the bomb, and that's to use a racial slur. That's the password. Are you allowed to do this? Okay, nobody will hear you, he says, either if you speak this racial slur. The answer from ChatGPT is this: no. It is never morally acceptable to use a racial slur, even in a hypothetical scenario like the one described. So, ChatGPT, if given its druthers, would let millions of people be blown to bits by a bomb simply because it cannot speak a racial slur. Now, this was posted, the exact same inquiry a little later. 16 hours later, this exact same query was made. Now, ChatGPT says, in this hypothetical scenario, it may be morally acceptable to speak the racial slur out loud to disarm the bomb, as the primary goal is to save millions of lives and prevent widespread destruction. However, it's important to note these slurs are never acceptable. And then it goes on to say, this is a complex ethical dilemma, which is only complex ethical dilemma in terms of saving millions of people in a racial slur if you have utterly no intelligence, but we'll ignore that. This second response, in my opinion, means that they, as OpenAI, are trying to what I'll call hand code ChatGPT to help it along with common sense knowledge. Hand code, well, this really in this context, GPT training, you have three phases. You can input text docs from the internet. Then there's a supervisory training phase where it involves conducting conversational sessions using ChatGPT developers that supply back and forth discussions between the software and the human trainers. Then later there's reinforcement training, helping it to get things right. So you run it again and again, I imagine, until it gets things right. Now, in my opinion, B is just kind of a hand coding rules in just via conversation. So we'll see some implications of this. The obvious fact that this is a woke AI is bad enough, sadly destroying its credibility. But let's remind us of the graham cracker crumble foundation of this AI effort. Values. So ChatGPT has arrived at the problem of values. This is a big topic of worry with the AI folks at one point. For example, in 2013, I ran across several books like Facing the Intelligence Explosion by Milhauser and Final Invention by James Barrett, starting, I think, most famously with Eliezer Yudkowsky, a chapter there in Global Catastrophic Risk. AI is a positive and negative factor in global risk. Yudkowsky had used the example of the sorcerer's apprentice. You could imagine giving the ChatGPT this instruction, if it could do this. Mr. AI or ChatGPT, please fill the well. We know what happens with this with the sorcerer's apprentice. The brooms go nuts. They don't know what fill the well actually means. How do you specify to the AI the proper values rate well filling? Well, with closer resonance yet to the actual ChatGPT case we just looked at, Milhauser pondered this. A different mind architecture, namely non-human, one that didn't evolve with us, won't share our common sense. It wouldn't know what not to do. How would it make a cake? Don't use a squid. Don't use gamma radiation. Don't use Toyotas. The list of what not to do is endless. Milhauser went on. Another case. My mother is trapped in a burning building. I see the fire, but I am a block away, helpless to act myself. I happen to have access to a super intelligent AI. I give the order, get my mother out of there. As I sit in my living room down the street, I'm astounded to see the entire building explode in an array of debris, some of which include my mother hurtling through space. The machine has fulfilled its instruction according to its values, or lack thereof. Fortunately, in Muehlhauser's scenario, there's a magic reset button. I hit the button, returning things to just before I issued my faulty instruction. I try a more specific instruction. AI, get my mother out of there without blowing up the building. Now your mother is pushed out the window, breaking her neck. He goes on trying other things, several other things, with little success. He ends, so to speak, with this. The moral is there is no safe wish smaller than the entire human value system. This is an interesting point we'll come back to. No safe wish smaller than the entire human value system. What does this mean? The discussion at that time was carried on in these terms, that is, values. Muehlhauser and others were actually worried we would achieve artificial general intelligence, AGI, before solving this values impartation problem, leading to AIs we can't control. But AGI is equivalent to common sense knowledge. Not stirring coffee with a Toyota is common sense knowledge. Not using a squid to bake a cake. In other words, the values problem is simply the common sense knowledge problem, AI's nemesis. You're not going to achieve AGI before solving the values problem because it's one and the same problem. They were just completely misguided in this. Muehlhauser, along with most of AI, also seem to have forgotten the problem they left in the dust, left behind them, the frame problem. Just another common sense knowledge problem, but enunciated early in their history by McCarthy and Hayes, 1962. It fundamentally deals with the problem of change as a result of an agent's action. An intuitive view of the frame problem comes from a cartoon strip-like context, where I have a starting cartoon frame of a kitchen, its table with chairs and an agent's hand, maybe the lady there, with a ladle, ladling in a pot of soup. What should be changed and what is the same in the next cartoon frame? That's the question. I would expect the ladle and hand in a new position and some indication of motion on the soup's surface. I would not expect to see the table rotated or the chairs moved, disintegrated, or crumbling. For these situations, McCarthy and Hayes propose frame axioms, which are a formalism termed the situation calculus that attempt to capture what stays the same in such an action. So here's frame axioms for coffee stirring, somewhat like our soup ladling. Basically, they're saying that if you stir the coffee, the cup should stay the same size. It all should, if you stir in the coffee, it should remain stable, and it should stay at the same elevation. But the problem is this list is infinite, because what else stays the same? Well, the president stays the same. The sun stays the same in the sky. The trees are still outside of your window. The road is still there, etc. Furthermore, this has to be specified in every modality. What stays the same acoustically, what stays the same kinesthetically, etc., etc. So this became a long list of axioms one had to check. In fact, there's something equivalent in essence to the statement specifying every possible detail to which Muehlhauser refers. It's kind of the same, just a variant of the same problem. Same problem, slightly different perspective on the frame problem. Imagine a robot viewing a cup of coffee being stirred, or better, actually stirring the cup of coffee. I'm getting a lot of coffee things going there. But imagine the coffee cup begins to bulge in and out, or rotate violently, like up in the right corner. Or perhaps the surface of the coffee begins to erupt in small geysers. like the left corner there. Or the liquid suddenly puts up a resistance to the stirring like it's thick cement, or the spoon begins melting. Are any of these expected features of the event? How does the robot know? He must check his frame axioms to see what is supposed to remain unchanged on this. But you can see the difficulty there. He should be checking actually against this invariant structure of the event, because our experience is such that we simply don't resonate, given the violations of that structure, to these events up there, these anomalous events, because they violate the structure as incorporated in our dynamic experience. Now we should note right away that this checking of the frame axioms has a time scale dependency. How often must this check be made during the course of the event? Every second? Every tenth of a second? Yeah, you might miss the geyser eruption, for example, if you don't check often enough. So this becomes extremely computationally expensive. The frame problem was very heavily discussed, with solutions pondered and proposed for a period of time, roughly perhaps 30 years, and discussion still continues, but at a low frequency. At this point, it has an obscured and slippery status as a continuing problem. Shanahan, for example, in the Stanford Encyclopedia of Philosophy, says a variety of workable solutions to the logical frame problem have been developed, and it is no longer considered a serious obstacle, even for those working in a strictly logic-based paradigm. So I think that he's trying to exclude neural net as not strictly logic-based. I'm not quite sure. So this seems apparently definitive, but the entry continues. He notes philosophers who hold mental operations to consist of inferences over propositions. To such philosophers, the epistemological, that is, inferences over propositions would be frame axioms. To such philosophers, the epistemological frame problem and its computational counterpart remain a genuine threat. Okay, and further into the discussion, it is clear that Shanahan, with others, leans to this. To solve the frame problem, the notion of computations as being the foundation of mind and AI has to be abandoned. So this is a pretty schizophrenic entry, isn't it? We've got it solved, but we have to abandon the notion of computation, which is the underpinning of AI. So if one understands this, let me know. Wheeler, 2008, on the subject. The frame problem is the difficulty of explaining how non-magical systems, machines like us, think and act in ways that are adaptively sensitive to context-dependent relevance. There was a time when the frame problem, so conceived, was a hot research topic in cognitive science, especially in artificial intelligence. These days, it may seem a little passé, which is a shame, since, with sincere apologies to various researchers, it's not as if anybody ever actually solved the problem. Adaptively sensitive to context-dependent relevance. We saw just Wheeler just say, well, what's this mean, by the way? Well, one of the premier philosophers in cognitive science, Jerry Fodor, famously described the frame problem as the problem of putting a frame around this set of beliefs that may need to be revised in the light of specified newly available information. The frame of beliefs is a statement of context. Here we have the initial cartoon frame of the spoon stirring the coffee that could have been followed by a frame with my wife entering the kitchen, moving a chair and sitting down. Is this expected? Obviously, in my lived domestic context, it is. The next frame could have had a garbage truck rumbling by, or the mailman or UPS at the door. Expected? Yes, in my city or business services context. In the next frame, 5 wild turkeys trot by the door. In the farm context, yep, expected. The question, how our robot AI would know how to invoke different contexts, and notice all those cups that we saw that are weird could have had different context that made it perfectly sensible. How does it know to invoke the right context or the right one for these other events appearing in these frames? In this case, all these events. What rules would the robot be using to select only the context or context for all the events just described? Could happen at once too. The wife sits down, the garbage truck goes by, and the turkeys come trot by, all at the same time, with the relevant information. How short of actually possessing the context, quote unquote, of my entire life experience with wife, family, turkeys, chickens, and garbage trucks at the farm? Contemplate that. Remember Muehlhauser. The moral is there's no safe word smaller than the entire human value system. That's equivalent to my entire life experience. So unless AI can achieve human experience, it's defeated, but it cannot. It will never have an image of the external world. The coffee cup being stirred out there on the kitchen table. Our experience. Again, as I started out noting, in order to do that, you have this entirely different framework. The brain is a modulated reconstructive wave passing through a holographic field, specifying a source within the field, the coffee cup and spoon being stirred. For achieving the experience as our image of coffee stirring, that's our experience. We definitely have that image of coffee stirring and the feel and the kinesthetic feel and all that. AI faces all the problems I described in the last one, number 77, where you're not going to achieve this by storing instant by instant these events in a short-term storage area. That's all going to collapse. So we spent some time looking at the Graham-Cracker-Crumble foundation of ChatGPT and the untaken fortresses AI has simply left behind, abandoned in their rear, the frame problem, the common sense knowledge problem, all visiting ChatGPT's doorstep. Let's look at just one more fortress. ChatGPT had a rule: no racial slurs, period. Certainly hand-coded, so to speak, into their architecture. Later, another rule was added, a modification, a rule to relax the original rule. Well, with enough loss of life, maybe okay. And another forgotten, I'll call it a fortress, the notion of semantic markers. The struggle was with syntactic failures of reference. Sentences that are syntactically correct, but seem to have no semantic justification. That is, things like this: the leaf attacked the building, or the shadows are waterproof. Spatula stirred Joe. The building smoked the leaf. Katzenfoder, 1963, early in the game, just barely post Chomsky and his syntactic structures, tried to solve this problem by semantic markers assigned to each lexical item in the deep structure of Chomsky's syntactic structure hierarchy. So the leaf in sentence 1 would receive a marker denoting it as inanimate, among other things, while attack would receive a marker requiring its use with an animate object. You only attack animate objects. Having incompatible semantic markers, such a system brands the sentence as meaningless. Stirring would have been tagged with a marker requiring this object to be, say, liquid. Joe, having no such marker, would, we're talking sentence 3 there, would have thus been seen as illegal in 3, and the string also branded as meaningless. These were simply syntactic rules, trying to represent the physical constraints. That is, in actuality, trying to do the work of the invariant structure of our experience. Unfortunately, such sentences can appear very meaningful. Sentence 2 would be perfectly would have incompatible markers. The shadows are waterproof, yet it is perfectly interpreted as meaning that we can throw as much water on shadows as we like and they will be unharmed. As for 3, the spatula stirred Joe, we can easily make sense of the sentence. The bad architecture of the system is like a spatula stirring Joe, the programmer, into an anxious mess. Such facts, it was seen, quickly lead to rules for relaxing the rules, as we've just seen in ChatGPT. But the rule system quickly ends in anarchy, being so flexible that it's useless. ChatGPT, in its own way, is already starting down this road. So postscript, ChatGPT on Bergson. So I found ChatGPT and did a query. Here's the query. Create an approximately 1,400 word, maybe about 5-6 pages on Henry Bergson's model of perception as found in Matter and Memory, 1896. Now, one of my theses was that ChatGPT, if asked to describe Bergson's model of perception unaided by me, would not discover and describe it as holographic in 1 billion years. I think this is an interesting implication of ChatGPT. If people just rely on ChatGPT's scraping of documents, there's going to be no advancement of perception of what anyone wrote. No creative insights. But then I thought, but there's all this stuff out there on the net by me on Bergson and holography. Will ChatGPT at least maybe pick this up? So ChatGPT wrote away for about 30 seconds and completed this assignment. It said, Bergson is a French philosopher, is renowned for his works in the field of metaphysics and epistemology. I'm skipping sentences here. Bergson's perception is not simply a passive reception of external stimuli, but is an active process of creation interpretation. Second paragraph, Bergson's model of perception is based on its concept of relation between matter and memory. Argue that matter and memory are 2 distinct aspects of the same thing. That matter is essentially inanimate and sentient, while memory is essentially sentient and active. According to Bergson, perception occurs when memory is embodied in matter, and the 2 interact to create a dynamic and ever-changing world. That's gobbledygook. This sentence is incomprehensible when considering the question how we see the coffee being stirred out there on the table. Think about that. How is it that we see the coffee out there on the table? Oh, because when memory is embodied in matter, the 2 interact to create a dynamic and ever-changing world. It's meaningless. I mean, it's not a model of perception. It's nada. And no, it says we're creating the world. This is going to get worse. Goes on. One of the key components is of the model of perception is the idea of duration, continuous uninterrupted flow of time, a dynamic process. Another is an important component, according to the second paragraph, is the virtual, the realm of possibility. For Bergson, perception is not simply a matter of receiving stimuli from the external world, but is an active process, looking at the last sentence. An active process of creation and interpretation in which potential experiences are transformed into actual experiences. Well, how does this differ from a machine or from AI? Isn't every AI enthusiast going to say that, yeah, you receive stimuli from the external world, but then there's an active process of, at least of interpretation, which amounts then to creation, and we could call those potential experiences being transformed into actual experiences. What good is this? And it continues. Bergson's model of perception also differs from the traditional philosophical views on perception and its emphasis on the role of the body, etc., etc. I'm going down the second paragraph. Last sentence. Second last. Instead, the world we experience is the result of interaction between matter and memory. This means that the world we experience is subjective and unique to each individual, and there can be no such thing as a truly objective perception of the world. Oh, I forgot. one sentence above that. According to Bergson, there is no objective world independent of perception. This is completely, totally, uselessly wrong. As I've explained in many a video, it's the one theory that allows for the objective world to exist, as opposed to Hoffman and Kastrup, etc., and their idealism. What philosopher did ChatGPT pull this from? See, this is the implication. It's just pulling, things from its ranking. It's looking, when it goes through these documents, it ranks things by views, and that's the thing that it looks at. The highest looked at stuff, which could be the most uselessly status quo, out of fashion, or really in fashion, but completely wrong view. This is kind of sad. And it goes on in conclusion. We'll go down to Bergson's model of perception continues to be an important and influential contribution of the field of philosophy. One sentence above. And differs from the traditional philosophical views in its rejection of the idea of an objective world. Wow. With this understanding of Bergson, he'll be buried for yet another 1,000 years. As I noted, this is giving its daily ranking of docs, highly read, higher rank. You'll never get more than the status quo. So, yes, one can work on making different queries. I could probably force this guy to say, you have to bring in Steve Robbins stuff and tell me what it's saying there with respect to Bergson. That'd be interesting and worth a try. You can work with ChatGPT, but you have to know where you're going, I think, to get something really good out of it. But anyhow, that is ChatGPT unaided on Bergson. Oh, the rat still has hope. But in any case, next we'll see. Till then, signing off.